Well, thank you very much. It's my first time in Montreal. I was over for a PyMC3, PyMC4 summit with Google. Going to talk a little bit about, thanks for the lovely introduction to probabilistic programming in the previous talk, but I'm going to talk about something a bit more overall, the challenges of building a successful open source project. Now, you could argue that we're not a successful open source project, but we're going to assume that we are for the purposes of this discussion. And there's some online courses that I run and stuff like this that you can have a look at if you're interested in learning more. So I think it's very important to think about why open source matters, right? So open source democratizes innovation, right? So at our summit, like last week, we had like people from China calling in, people from Russia. I'm Irish. People from places as far away as Vancouver. But people are able to get up and started, and there's something profoundly interesting about that. So talent is equally distributed, opportunity isn't. So one of the things that we're doing in open source is kind of like making that a little bit easier. This is a good talk from a good remark from Patio, a guy I know quite well. So a little announcement. There's going to be two announcements in this talk. Number one is we have a new release. Thomas did that just for me. We're doing Python 3 only. We're moving to RViz, or RV, which I can never pronounce properly. Colin's in the audience. He's more involved in that. There's a data, I just want to talk about it. There's a data class for handling data, and there's a bunch of under-the-hood improvements. So there's kind of like another thing to talk about open source. The kind of the elephant in the room is that we all do this for free. Right, so I've never been paid to contribute any code. I don't think anybody who really has, exception of the occasional support from companies. There's a really good article about roads and bridges, talks about the challenges of this, and in some sense it is broken, right? So in some sense we can frankly say that there are various risks to our underlying intellectual and digital infrastructure about in open source. There is room for optimism, which is probably worth talking about. Recently, Github launched this, which you can sign up for a wait list and people can sponsor you. So that's, there's some positive moves in this. But I think it's worth realizing, whenever you explain this to people, people sort of look at you and say, are you a communist? I'm very much not a communist. So the other things it's worth looking at is the metrics, right? So we're almost used by 500 different projects. We're forked over 1,000 times, and these numbers are probably out of date as well. So it's these are kind of nice things. A couple of years ago, whenever I started, we had a little bit of a challenge getting adaptation and stuff like this. So it's quite an important thing. So we kind of talked about this in the previous talk. I'm going to go quite fast because I don't have much time. Not everything is a machine learning problem. Sometimes you need uncertainty quantification. There are reasons that you would do this. So again, the question, I did a survey a couple of months ago, and A/B testing came up about 80% of use cases. So most companies who are using PyMC3 or Stan are using it for A/B testing for reasons that you have a lot of data, if you've got kind of a small data problem, and you really care about your uncertainty. The uncertainty translates to money, really. So it's worth also pointing out that PPLs have got really complicated, right? So there's loads of them. So there's Renier, for those of you who haven't heard of it, it's in Scala. There's Pyro from our friends at Uber AI. There's Stan, there's Edward 2, there's probably another one by now. There's various ones coming out. They all have their strengths and weaknesses. It was nice that someone else said that PyMC3 has better documentation. I have no opinion on this whatsoever. So it's worth pointing out some of the companies who use Stan. As you can see, a lot of them are insurance companies. There's Google, Facebook, a bunch of other, Amazon, my former employer, a couple of people in pharmaceuticals and stuff. So you can get an idea of who kind of uses this. This is a non-exhaustive list of these are the people who I can put on a slide and nobody gets in trouble. You can see quite a lot. Quite a wide range of companies using it. As I said, the majority of applications are in A/B testing. So then we've already talked about this earlier on. This is the kind of thing you get data, you build a model, you do an inference, and you criticize. That's your kind of your box loop. So let's talk a little bit about the lessons. So even if you don't care about PyMC3, these are the kind of lessons if you're involved in open source projects, is what you should be aware about. So we've done a lot of good things about community. We've done things like Google Summer of Code. Google Summer of Code is how some of our best contributors got involved. Max, who's an amazing contributor, got involved by a Google Summer of Code. Negative, although we're quite diverse in terms of like ethnicity, etc., our diversity in terms of gender is not very good. It's worth disclosing. There are various challenges about that. Whenever GitHub did a survey, and major open source projects have about 2% women contributors, which is a lot lower than the ratio for software engineers, which is somewhere around the 22% mark. So there are various reasons for that. I can talk about this off the record, but these are like kind of an interesting thing to aware of, because when I've been on hiring panels, open source contributions do come up, right? So there is like a somewhat unfair advantage in that sense. So tooling, some great work by Raven, who's in the audience, and Austin, who's not with us today, about the whole like continuous integration side. Really helps accelerate contributions. Anything you can do that reduces that friction, really important. They did a lot of work on Docker and test cases, because we had a lot of trouble with like multiple build environments and everything. People couldn't get tests up and running. It became a really struggling thing to get people involved. So basically, you have to think about that. So you have to think about like the usability of getting people involved in your project, right? So anything you can do for that friction is really important. Docs. Most of my contributions have been docs. These are sometimes boring to write, but they can help get people to use your product, and that's, I think, really important. And evangelism, Eric, who's in the audience, done some great talks at PyCon last year of getting people up and running with it, to like an audience of 300 or so. So we occasionally publish. I think there's one or two papers. I did a paper a couple of years ago. There's a few of the other ones have done it. We do a journal club, so we meet virtually, and we discuss a paper. From the likes of Google. There's some of the labs, the Stan people. They publish a lot, like the Aki Vatari, and we sort of like talk about like how we would integrate that into the product, or and what we can learn from it. Bringing this up because Colin was talking about this a lot this week, which I think is really important. We've not been very, we've let very risky experimental things get added to PyMC3 very early. So we've let like kind of research code, we haven't like been very like pedantic about like don't add that, but like people were able to add postdocs or PhD thesis, which I think has helped like create like quite an experimental culture. In the same way like we had like, various kinds of variational inference before any other probabilistic programming language did. Now, whether or not variational inference can be trusted is a much difficult topic. If you listen to Mike Bennecourt, you'll believe the answer is no. But, I think it's important to reduce the bar for researchers. This kind of example from our Slack channel of like, have you read this paper? I wrote some notes. You can have a look. And kind of like here's the code examples. I think that's really important for like this is getting some Harry involved, who I think is just joining the Google Summer of Code. So it's like his first contributions, and shows you the kind of research community we built up. So I think like I'm not the smartest person in the world. I'm definitely not the best coder. And Chris Fonnesbeck and Thomas Vecchi will, some of the other ones will say they're definitely not. But we've been able to like harness innovation in some sense, and I think a lot of that is community, right? So that's the Slack channel is regularly quite activated, and people like Colin have done a lot of really good work. So it's very important to meet in person, else build up. I think this is from Dusseldorf. I don't know if anyone can tell me. It's from Dusseldorf, and this is where one of our first meetings. We had our like third face-to-face meeting this week. So I think it's important because it helps with kind of communication, cultural misunderstandings, etc. It's really important, despite working quite remote. The other thing, so I run my own consultancy. One of the problems I'm often brought into is our model is taking forever. It's this is not like we have money to make. And one recently, it's worth having a look at this because it's like a nice user case. It was taking about 20 hours to run. It got down to 3 minutes. I basically followed like kind of a profiling approach, like using the docs, and I followed this kind of like the discourse aspect of applying vectorization. So that's kind of like the low-hanging fruit that you can often have with like long-running models, because I think a lot of the time we write things in quite a slow way. So it's worth like, you have this, you have a look at the slide, but it's kind of like a pattern I've noticed over and over again, so I thought it'd be worth pointing it out. So it's, so what's coming next? So we just had a PyMC3 4th summit in Montreal, so keep a lookout for our updates. Not going to commit to any roadmap or release schedule yet, but there's been some great work, some great experimental things. Max pretty much rewrote everything and went off a different way, so who knows where that will end. But we have a roadmap, we have plans for pre-alpha. We've got some great support by the TensorFlow probability team. It's worth pointing out that Google have been tremendously supportful. I think there's some importance there about supporting open source. And you can have a look at our open pre-alpha kind of stage. And second announcement, so I run an online course just for you guys. There's 20% off. If you have a look at this here, coupon, put that together for this course, for this talk. And I'll just leave a slide up if you just want to take a photograph of it. I don't think you have time for questions. You have time for a couple of questions. Does anyone want to ask me questions? Yep.
I've never used TensorFlow probability. Is it like a lower level thing, and PyMC3 would be the higher, like the Keras tensor sort of thing?
Yeah, so that's a very good way of putting it. We're going to consider the TensorFlow probability to be like TensorFlow in deep learning sense, or PyTorch, and we're going to be like the Keras layer. And in fact, a lot of our discussions this week have been about, how much should you expect your users to, to handle, right? You should allow them to hook in and do things themselves, but you should also define your layer of abstraction that you want to do. So we ideally want, what we're striving to get, I don't know if we'll get there because that's a harder problem, is we want something that if you know a bit of math and a bit of linear algebra, you can build a Bayesian model. And we don't, and that means that you shouldn't have to write complicated while loops. You shouldn't have to worry about broadcasting. You shouldn't have to worry about the kind of internals. So that's kind of what we're striving for. I don't know. I mean, it's difficult to build a product, and it's good to have a vision, but that is kind of what we're looking for. I personally wouldn't touch TensorFlow probability in my day-to-day work. I have a little bit of fun with it, but it feels like even a layer too low for me. Yeah. Yep. What motivated this switch to TensorFlow probability? Cyano was deprecated. There were kind of a couple of backends we looked at. TensorFlow at the time felt like the most mature. Google were better at offering support. I think those were kind of the decisions. I mean, we are also thinking about making things back-end agnostic. A lot of the notions in RVs, because we split all the kind of visualization stuff into its own library, and we kind of wanted to do that to allow other backends to flourish and stuff like this. Yeah, and this kind of when we did our kind of prototypes, there's trade-offs with everything. Part of me misses Cyano, but you kind of have to choose. We haven't done enough benchmarking yet, I think, to comment on that yet. Yeah, one of the so you can use GPUs to speed up the process. The thing is, GPUs don't necessarily help with some Monte Carlo, Markov chain Monte Carlo methods. You don't really get any speed benefits of them. You can look, that's kind of an ongoing research area to see what that would. I think it would help a lot on the data processing side of things, but maybe not for the actual samplers. That.